We're going to look now at some more differentiation rules, and that's the derivative of a to the x and the derivative of log base a to the x, where a here and here are real numbers. Okay, we are used to differentiating e to the x and log base e of x. Okay, so these are the rules. Okay, when we differentiate some real number to the power of x, and then we multiply that function a to the x by the natural log of a. The derivative of log the base a of x is 1 over x times the natural log of our base a. Okay, so we're just going to apply that to a few examples. The first one here is fairly simple. Okay, we have y equals 3 to the x, and if we apply our rule, then y dash or dy dx is equal to 3 to the power of x times the natural log of 3. Second example, then, we have y equals 3 to the square root of x. Okay, so we have here a function of a function, and when we do that we need to multiply the derivative of the square root of x by the derivative of 3 to the square root of x. So multiplying the derivative of the inside part by the derivative of the outside part. So y dash is going to be equal to the derivative of the square root of x, and if you remember, the derivative of the square root of x, that's the same as the derivative of x to the half, which is 1 over 2 root x. Okay, so we have 1 over 2 root x multiplied by, applying our rule, 3 to the x times the natural log of 3. Then if we put that together, the derivative dy dx is equal to 3 to the power of x times log of 3 all over 2 root x. So that's our second function, second example. We'll go over the page and look at our third example. Okay, slightly more complicated. We've got two functions here. Okay, so y equals x squared plus 1 to the 10th power plus 10 to the power of x squared plus 1. So what we can do, we notice here that we've got x squared plus 1 and x squared plus 1 both the same here. We could let u equal x squared plus 1, and so y equals u to the 10th power plus 10 to the u. So then differentiating that, dy du is going to be 10 u to the power of 9 plus 10 to the power of u times the natural log of 10. And then of course differentiating u with respect to x, we have 2x. We need to multiply them together then. Okay, so y dash or dy dx is equal to the product of those two derivatives, 2x times 10 times u to the 9. Remember, u is x squared plus 1, so that's x squared plus 1 to the power of 9 plus 10 to the power of u, which is x squared plus 1 times the natural log of 10. And there's our answer. We can leave it like that. You could expand it, but it's not necessary. Okay, so we'll keep scrolling down and we'll look at our next example. 4. We've got f of x is equal to log of the cube root of 2x plus 5 all squared inside there. When we just have log and there's no base written, that's the same as log the base 10. Okay, so log the same as log base 10. Right. So how else can we write this? We've got log of 2x plus 5. We've got here 2 powers we can combine together, so it's the same as the power of 2/3. Remember, the cube root's the same as power of 1/3, and then we multiply those together. Okay. So then, applying our log laws, we can take this 2/3 out the front. So that's the same as 2/3 times log base 10 of 2x plus 5. And we've got a composite function here. So we need to multiply the derivative of 2x plus 5 by the derivative of the whole part. Okay, so that's 2. That's our derivative of 2x plus 5, multiplying that by 2/3 times the log of that is going to be 1 over 2x plus 5 times the natural log of 10, because that's our base here. And we can just simplify that. 2's multiplied together giving us 4, and on the bottom let's put these 3 and 2x plus 5 together. So that's, in brackets, 6x plus 15 times the natural log of 10. And that's our derivative. Actually, I need to correct this a little bit. This is not equal to f of x. That's equal to f of x. And so is this. But here we're looking at f dash of x. Okay, that's our derivative. Okay, and we'll look now at our last example. Example number 5. We have y equals 2 to the power of 2x plus 1 plus log base 2 of x to the power of 4 plus 4. So we can treat these functions separately. Okay, so dy dx, the derivative of this, we need to multiply the derivative of power, okay, because it's a composite function. That's 2 times, okay, and now this part is 2 to the 2x plus 1 times the natural log of our base here, which is 2. Plus, similar with this one. Okay, we need to multiply, being a composite function, the derivative of this inside part, 4x cubed times, and now we apply our new rule, which is 1 over x to the 4th power plus 4 times the natural log of 2. And we can simplify. Okay, we've got the same base here, so remember when we multiply, we add the indices. That's 2 to the power of 1 plus 2x plus 1, so that becomes now 2 to the 2x plus 2 times log 2 plus, simplifying this second one, 4x cubed over x power of 4 plus 4 times log of 2. And that's our answer. Okay, so that's our work on those. And in our next video, we'll look at some derivatives of the inverse circular functions, okay, arc sine, arc cosine and arc tan, okay, and after we've done those examples, then there's a series of questions we can do. You could begin on these and pick out the ones that don't have the inverse trig functions for the moment. Okay, that wouldn't be a bad idea, but you could wait as well. Okay, so that's it.